Okay, here we go. On the first problem, do you remember when I'd say like 2 by 3 or 3 by 2, what comes first, rows or columns? Rows. All right, so the rows here and the columns are here. So this is a 2 by 3. Then what's this one over here? A 3 by 2. Look at these numbers. Do they match up? So this will work. But, and it's a big but, let me tell you. If you switch it around backwards and we were to put the 3 by 2 over here and the 2 by 3 over here, it still works. Will it always work? No, it won't always work. So if this had been a 1 here, and then all of a sudden it's a 1 here, you see how it wouldn't work? So the point is that if you switch around and the matrices and you put the 1 that's on the right over to the left side, you do not get the same answer every time. Okay? So I don't want to go through this because frankly it takes too much time to prove it by doing it. It doesn't take that long. If we do AB, oh boy. Okay. I gotta hold really still. Rats. Okay, anyway. There might be some crackling because my microphone is bad. I'm just going to try to ignore it. So anyway, I think more than ever I do not have time to show you, but it's true that if you switch them from left to right, they won't keep working. All right, so that only works, it's not commutative anymore. Normally like 3 times 2 is equal to 2 times 3, but not with matrices. Okay, moving on. If I had this matrix, the Z right here, this Z matrix, it would have to be a certain size to make this work. Do you get that that's a 2 by 2, and then the mystery matrix, the Z matrix, and then the answer is a 2 by 1. If you think about it, you can figure out that this has to be something by something. First of all, would you agree that that first number has to be a 2? All right. Then the other number does not have to be a 2. Remember how this one goes with this one and tells us that the answer matrix will look like this. So this must be a 1. All right, so let's say this. Let's say we had a 3 by 5, and we're going to multiply it by a something by something, and we're going to get a 4 by 7. Is that even possible? Okay, because first of all, this number right here would have to be a what? 5. And so that means that this would have to be a 5. All right. I'm wrong. You're right. This number comes from here, so that'd have to be a 3. And the answer to this one, the question mark would have to be a 7. You're correct. Okay, so that was still possible. If this number had been a 3, we could have made it work. All right, so let's say that that's a 3. Then final answer, I'd need a something by something matrix. That has to be 5, so that matches that. And then this would be a 7, so that this 3 by 7 answer. Okay, that's an easy kind of problem. Let's move on. There's some cool stuff on your calculator that I need to show you for today. So grab your graphing calculator. If you don't have one, borrow one from me. Make it fast. I'll pause while you do that. Okay, so here is a typical problem, and you are going to really like this for solving hard problems on the SAT test, the ACT test, and even on like the state math tests. Whenever they give you a set of equations like this, these can take a while to solve, especially if they have like 3 variables, x, y, and z, and then trying to find what each of them is. That can be a pain. And this matrix, a matrix can do this. All right, first of all, what matrix would you have for this? You would make a matrix that has this, this, and this number, 4, -5, and 33, and that, which is a -1, that and that number. And, oops, I shouldn't have closed my matrix down there. -1, 5, and -27. Do you get where I got those numbers? So it's a matrix. Sometimes they have a line right here, which is completely irrelevant, but sometimes there's a line there, sometimes there's not. All right, that's an augmented matrix, has a line in there. Big deal, doesn't do much. Okay, So if I'm going to solve this problem and make the calculator do it for me, of course the matrix button is going to come in handy. So everybody find the matrix button on your calculator. All right, so once you hit the matrix button, it's the one that's red up on the screen here. It's right above that one. The matrix button, the first thing you see here is the names. That's matrix A, B, C, D, E, F, and G. It would have been nicer if they'd have given them creative names like albatross and buckshot and whatever. Okay, but, oh man, crinkly noise starting again. Okay, we're back from lunch and we're going to try this again. The microphone seems to be working. All right, so you've got your calculator and hopefully you've pressed the matrix button. And that means that you're now able to put in a matrix. The one I have in the upper right-hand corner here with the 4 and the 5, -5, 33, etc. We're going to put in that matrix into the calculator. So would you please go over to Edit, because we need to edit matrix A. So we go over to Edit and hit Enter on number 1. And now that says it's a 1-by-1 matrix, but it's not. It is a 2-by-3. So go ahead and hit Enter 2, Enter 3, Enter. Now it knows it's a 2-by-3 and it puts up 6 zeros for you. And now you fill in the spots. 4 and then -5. Don't forget to use the negative key, not the minus. -5 and then 33. And just hit Enter again and go down to the next row. -1 and 5 and 27. Very simple, very easy. Uh-oh, I gotta put in a negative. I gotta back up. And second, insert a negative. It doesn't look like it wants to be nice. There we go. Okay, now we need to get out of here, so hit second quit. Once you got your matrix entered, go second quit. All right, now we got a nice clean blank screen. Now, if we wanted to take that matrix and have it tell us the answer for what is X, what is Y, like here's the equation, right? It was X has got to be something and Y has got to be something. It can tell us that answer if we do what's called rref. It's under matrix again. And you go over to math. And it's the, well, I'm just going to arrow down until you see it here. It ends up being B, you're right, but if you arrow down enough, you'll get to rref. There it is. And that stands for Reduced Row Echelon Form. You probably will never, well, no, not never. You'll hear about it again, but the name is not that important. rref, what it does is what's important. rref, and we need to do this to which matrix? Matrix A. So now I got to go back into the matrix thing. Matrix A, enter. So now it's going to rref, reduced row echelon form of A. I'm going to hit the end parentheses just because it looks more complete if I do. You really don't have to, but hit enter. Now I know that doesn't look like an answer, but it is. Do you remember what was in the first column? Those were X's or Y's in the first column. Those were the X's. And see how there's a 1 up there at the top? That's trying to say that 1 X and 0 Y's would be 2. So that's basically telling you that X equals 2. You get that? And 0 X's plus 1 Y would equal -5. So basically it's telling you that Y is -5. So it's told you that X is 2 and Y is -5, so that's the answer to the system of equations. Now, what if you'd just graphed it? Couldn't you just graphed it and saw where the two lines crossed and it would be crossing at 2, -5? Yes, that's one way you could have done it. But when you have 3 variables, X and Y and Z, that takes a 3-dimensional graph. But we can just do it with the same exact thing, the rref, on our matrix. We can just do it the same exact way. All right, so let's do a triple matrix this time. So everybody go back in. Actually, we should use a real problem because I tried this in a different hour and it didn't work so good when you don't just try to make up the numbers. We're going to do this triple one right here because it has an answer. Think about this. Any two lines will cross, or they'll be parallel, one or the other. Do you know what I'm talking about? As long as they have a different slope than each other, any two lines would cross. But in 3 dimensions, can you picture how a line that's over here and a line that's over here don't necessarily have to cross? Because you're in 3 dimensions. It's hard for me to... People at home can't see this, but basically if you were to hold up like 2 sticks in the air in 3 dimensions, there's a lot of ways you could hold them so they wouldn't ever touch. So anyway, if you aren't careful, your lines won't touch. Well, these do. All 3 of these would touch at one spot in space. And that's a spot for X and a Y and a Z. Now, if you're putting this into a matrix, I think you can see this would be a 1, and then a 10, and then a -2, and then a 20. That's your first row, and that's pretty easy. And then 5, -3, 4, and 8, 2, and 1, and then wait a minute, there's not enough spot. Exactly, you've put in a 0Z, and I'm just moved this 6 over here. Say equals 6. And 0 goes in. When there isn't a Z, you put in a 0 and a 6. So those are my numbers right there I want you to put into your calculator. Okay, this is under matrix. I would use the same matrix. I'd use matrix A. If some of you already used B, that's fine. But if you can just change matrix A to be a, how many rows? 3 by 4 matrix. All right, I'll pause for a second while I put that in my calculator. Okay, now one of the cool things is that if I use the same matrix, I used A like I did the first time. Yeah, it's recording. If I use A like I did the first time, then I can go back and use the feature on the calculator here that lets me to just do the same exact thing over again. And that's up above the enter key. There's the entry thing. See how it says rref? See what I mean? I don't have to go retype all that junk. I can just go back and have that same thing and hit enter, and now it does the same problem again except with my new matrix. See what I mean? That was right above the enter key. There's that entry thing. And if you want to go back and look at all the old things you've typed for the last week, you can go back and look at all the old things you've typed by hitting second entry, and it'll keep going back and back and back, and you can keep looking at old problems you did a lot of times ago. Okay, anyway. But how do we read this answer? You see that top row? That means 1x, 0 y's, and 0 z's would equal 2. See what I'm saying? So it's telling you x is 2, y is 2, and z is 1. Raise your hand if you got that one right. You got it correct. Okay, good. If you didn't, it's probably just because you didn't type the right numbers into your chart. It's really easy to get one messed up. I got one messed up on the last problem. So, okay. So that's all there is to it. If you know how to put these into your calculator and do rref, it'll solve that system of equations for you. There's a process for doing it by hand, but it's one of these things that you'd probably never use the rest of your life. Whereas this calculator, if you just remember rref, it'll answer all those kinds of systems of equations problems for you on all the major tests, and you're allowed to use this calculator on all your major tests. So whenever you see a system like this, think about using rref to solve it in a matrix. And that's it for today.